The primary goal in this data analysis is to understand what sort of differences we might see if the null hypothesis was true, that the treatment had no effect on students. That is, we want to see what does random chance look like, and then let's compare our sample to that. To achieve this, we'll use the same randomization procedure that we applied before. We'll find what randomization looks like under the null hypothesis, then see how the point estimate compares. If the null hypothesis was true and the treatment had no impact on students' decisions, then the observed difference between the two groups of 20% would be attributed entirely to chance. On the other hand, the alternative hypothesis is true. If that is true, then the difference indicates that reminding students about saving for later purchases actually impacts their buying decisions. That is, if the null hypothesis was true, then the results we're seeing is just random chance. If the alternative is true, then the results we're seeing is an actual effect of giving students that extra reminder. Now, while we would in reality do this simulation with a computer, and we will in a moment, it might be useful to think about how we would go about carrying out the simulation with cards instead. So we start off with the original table without the cells, without the middle part. And since my overall total is 150, I would start with 150 cards and label each card to indicate whether they're in the treatment group or the control group. So that is 75 cards would be labeled treatment and 75 would be labeled control. Then we take those 150 cards and shuffle thoroughly, and I'll deal with the 53 people who did not buy. So I'll deal out 53 cards, and these represent the simulated decision to not buy the DVD. Any observed differences between the proportions in these cards is entirely due to chance. Let's just say I went about and did a simulation, and here are my results. From this table, we can compute the difference that occurred from chance alone. So my simulated point estimate, my treatment group was 24 out of 75, so 24 75ths, and I subtract off the control group success of 29 out of 75. So 0.32 minus 0.37 is about negative 0.067. Negative in this case would mean that the control group was thriftier than the treatment group, and that's something we could expect from random chance. Just one simulation will not be enough to get a sense of what sorts of differences would happen by random chance alone. We need to do this over and over and over again. So we'll simulate another set of groups and compute the new difference, 0.013. We'll do it again, 0.067. We'll do it again, give me like negative 0.173. We'll do this 1,000 times. Using the Rossman Chance apps, again, I'm going to choose randomization test for categorical response. Say it's a 2x2 table. I'll put in the original table, which was 34, 19, 41, 56. Click to use the table. And you can see down here, bottom, there's the point estimate, 0.2. I want to do randomizations, simulations. So click to show shuffle options. Let's choose 1,000. Shuffle. And here's what random chance looks like. Notice a lot of the results are right here around 0. This would represent no difference, which is what we expect from random chance. And what I want to do now is count what proportion, 0.2 is around here, what proportion is around 0.2 or more. So I want to count the samples that are greater than or equal to 0.2. Count. I see in this case, this occurred less than 1% of the time, about 0.8%.